In an increasingly connected world, pocket-carried devices such as smartphones, key fobs, RFID cards, wireless earbuds, smartwatches, and portable power banks emit non-ionizing electromagnetic signals, including radiofrequency radiation, electromagnetic fields, microwave radiation, and RFID signals. These signals raise concerns about privacy, security, and potential health effects, while device-generated heat poses risks of skin discomfort or, in rare cases, burns. Faraday bags, functioning as portable Faraday cages, block these signals to protect against hacking, tracking, and exposure concerns, while thermal pouches mitigate heat. Pocket-sized Faraday bags offer a convenient single solution for carrying multiple devices, but no reputable manufacturer currently integrates robust signal blocking with dedicated thermal protection in a single product. This article provides a comprehensive overview of electromagnetic signals, Faraday bag functionality, thermal management, pocket-sized options, additional risks, and how to achieve maximum protection using separate solutions. Electromagnetic signals from pocket devices. Pocket devices emit various non-ionizing electromagnetic signals, each with distinct frequencies and potential risks. Radiofrequency radiation spans 100 kHz to 40 GHz, encompassing cellular signals from 700 MHz to 39 GHz for 4G and 5G. Wi-Fi and Bluetooth at 2.4 GHz and 5 GHz, GPS at 1.2 to 1.6 GHz, and key fob signals at 300 to 900 MHz, such as 315 MHz in the US and 433.92 MHz in Europe. Microwave radiation, a subset of RF radiation from 300 MHz to 300 GHz, includes high-frequency signals like 5G and Wi-Fi. Electromagnetic fields include high-frequency EMF from wireless devices and low-frequency, extremely low-frequency EMF at 50 to 60 Hz from batteries or power lines. RFID and NFC signals, operating at 125 kHz to 13.56 MHz, enable short-range communication in credit cards, passports, and access cards. These signals enable connectivity, but pose risks. Privacy concerns include hacking or tracking via cellular, Wi-Fi, or GPS signals, while security risks involve RFID skimming or key fob relay attacks that enable car theft. Health concerns, though not conclusively proven, include thermal effects, where RF radiation causes slight tissue heating, regulated by FCC-specific absorption rate limits below 1.6 W/kg in the U.S. Debated non-thermal effects, such as sleep disruption or rare links to tumors, are classified by the International Agency for Research on Cancer as possibly carcinogenic, Group 2B, with limited evidence. Devices also generate physical heat from batteries or processors during heavy use, such as gaming or charging, which can cause skin irritation or discomfort, particularly when carried near sensitive areas like reproductive organs. How Faraday bags block electromagnetic signals. Faraday bags, inspired by Michael Faraday's 1836 discovery of electromagnetic shielding, are portable enclosures that block electromagnetic signals by creating a Faraday cage. Constructed with 2 to 3 layers of conductive materials, such as copper, nickel, or silver mesh woven into durable fabrics like 600D nylon or ballistic nylon, they absorb and dissipate electromagnetic waves, preventing signals from entering or exiting. Secure closures such as roll-top, magnetic, or double Velcro ensure no signal leakage. High-quality Faraday bags block a broad frequency range of 100 kHz to 40 GHz, covering cellular, Wi-Fi, Bluetooth, GPS, RFID, and key fob signals, with attenuation of 80 to 100 dB, reducing signal strength by factors of 1 million to 1 billion. These bags protect against hacking, tracking, RFID skimming, and key fob relay attacks, while also addressing RF exposure concerns by eliminating thermal effects and improving non-thermal effects. Certifications like MILSTD 188-125-2 for electromagnetic pulse protection or IEEE 299-2006 for shielding effectiveness validate their performance, making them trusted by military, law enforcement, and privacy experts for applications like digital forensics, anti-theft protection, and EMF reduction. Pocket-sized Faraday bags for phones and key fobs. Pocket-sized Faraday bags are designed to hold multiple devices, such as a smartphone, key fobs, RFID cards, and small items like wireless earbuds, in a single compact enclosure that fits comfortably in a pocket, typically measuring 7 to 8 inches by 4 to 5 inches internally. These bags block all relevant signals, RF, EMF, microwaves, and RFID, ensuring privacy, security, and reduced exposure in a portable format. They use the same multi-layer conductive materials and secure closures as larger Faraday bags, offering 80 to 100 dB attenuation across 100 kHz to 40 GHz. Recent 2024 to 2025 reviews highlight their effectiveness in blocking cellular, Wi-Fi, Bluetooth, GPS, RFID, and key fob signals, with roll-top closures noted for reliability in preventing signal leakage. These bags consolidate devices into one enclosure, reducing bulk compared to separate pouches for phones and fobs, making them ideal for daily carry in pockets, purses, or small bags. They provide a practical solution for users seeking comprehensive signal blocking without managing multiple bags, addressing privacy concerns like tracking and security risks like key fob theft. Limitations of Faraday bags, including thermal protection. Faraday bags excel at blocking high-frequency EMF and RF signals, but are less effective against low-frequency, extremely low-frequency EMF at 50 to 60 Hz, which requires specialized magnetic shielding like mu metal. They do not block ionizing radiation, such as X-rays, which is irrelevant for consumer devices, or static magnetic fields from device magnets, like those in phone cases or speakers, which pose minimal health risks but may interfere with pacemakers. Physical damage to bags, such as torn seams or worn closures, can compromise shielding, necessitating durable materials and regular inspections. Critically, no reputable manufacturer in 2025 advertises a Faraday bag that fully integrates broad-spectrum signal blocking, 100 kHz, 40 GHz, 80 to 100 dB, with dedicated thermal protection equivalent to a neoprene or silicone sleeve. Faraday bags do not protect against device-generated heat, which can cause skin discomfort or, rarely, burns when devices like phones or power banks overheat in pockets. Their non-breathable conductive layers can trap heat, potentially increasing device temperature. Some advanced Faraday bags include breathable linings, like felt or foam, or fire-resistant materials, such as aramid-based fabrics, which offer minor heat relief by reducing direct contact with hot devices. But these are not marketed as thermal protection solutions, and are significantly less effective than dedicated thermal pouches. Thermal protection, a necessary separate solution. To address heat-related risks, a separate thermal pouch is required. Made from materials like neoprene, silicone, or heat-resistant fabrics such as aramid, thermal pouches insulate against device heat, typically withstanding 120 degrees Fahrenheit to 150 degrees Fahrenheit, preventing skin discomfort or damage to devices. For maximum protection, devices can be placed in a thin thermal sleeve before insertion into a Faraday bag, ensuring both signal blocking and heat management without compromising the bag's seal. Alternatively, a thermal pouch can be used during active device use, such as calls or gaming, with the Faraday bag employed when devices are idle. Devices should not be overheating or charging when placed in either pouch to avoid trapped heat. Additional considerations for comprehensive protection. Beyond RF, EMF, RFID, microwaves, and heat, several additional risks should be considered. Static magnetic fields. Device magnets, such as in MagSafe phone cases, generate static or low-frequency magnetic fields not blocked by Faraday bags. These pose minimal health risks but may affect pacemakers or magnetize credit card strips. Mu metal pouches, available for $20 to $50, provide magnetic shielding if needed. Chemical exposure. Materials like nickel in device casings or rarely, leaking batteries in vapes can cause skin irritation or allergies. Hypoallergenic linings in Faraday bags, such as cotton or felt, or silicone device sleeves minimize contact risks. Physical damage. Wear and tear on Faraday bags can reduce shielding effectiveness, while damaged devices may overheat or malfunction. Durable, water-resistant shells and protective device cases, like silicone covers, prevent such issues. Non-electromagnetic signals. Sound or vibration from device notifications can compromise privacy. Enabling silent mode or using sound-dampening pouches addresses this minor concern. Selecting the best pocket-sized Faraday bag. To choose a pocket-sized Faraday bag that blocks all relevant signals for phones and key fobs, prioritize. Frequency range: 100 kHz to 40 GHz, covering cellular, Wi-Fi, Bluetooth, GPS, RFID, and key fob signals. Attenuation: 80 to 100 dB for near-complete signal blocking. Effective even in high-interference areas. Certifications: MIL-STD 188-125-2 or IEEE 299-2006 for military-grade shielding against RF, EMF, and EMPs. Materials: 2 to 3 conductive layers of copper, nickel, or silver mesh in a water-resistant, puncture-resistant shell like ballistic nylon, with a non-abrasive lining like felt for minor heat relief. Closure: roll top or magnetic for a secure seal. Preferred in recent reviews for reliability. Size: 7 to 8 inches by 4 to 5 inches internally to fit a smartphone up to 6.8 to 7 inches, key fobs, and RFID cards without overstuffing, ensuring pocket friendliness. Additional features: external non-shielded pockets, keychain loops, or belt clips for convenience, as noted in 2024 to 2025 product listings. Testing is essential. Place a phone in the bag and call it. The call should fail. Test key fobs by attempting to unlock a car, which should fail, and RFID cards by scanning, which should also fail. Signal detector apps can confirm attenuation. Avoid cheap, unbranded bags under $5 with vague claims or single-layer materials, as they often fail to block high-frequency signals like 5G. Combining signal and thermal protection. No single Faraday bag fully integrates dedicated thermal protection with broad-spectrum signal blocking. For comprehensive protection, place devices in a thin neoprene or silicone sleeve, heat-resistant to 120 to 150 degrees Fahrenheit, before inserting them into a pocket-sized Faraday bag. This layered approach blocks all signals while insulating against heat, fitting comfortably in a pocket. Alternatively, use a thermal pouch during active phone use and a Faraday bag when idle. Some Faraday bags with breathable linings offer minor heat relief, but a dedicated thermal sleeve is more effective. Ensure devices are cool before placement to avoid heat buildup. Practical implementation for pocket carry. A single pocket-sized Faraday bag, measuring 7 by 5 inches with 80 to 100 dB attenuation and a roll-top closure, can hold a phone, key fobs, and RFID cards, blocking all signals while fitting in a pocket. Pairing with a slim thermal sleeve minimizes heat discomfort, maintaining portability. For flexibility, separate pouches. A small Faraday pouch for fobs and cards and a thermal pouch for the phone. Allow active phone use while keeping other devices shielded. Faraday line backpacks or wallets are alternatives for larger items or travel, but are less pocket-friendly. Conclusion: pocket-sized Faraday bags provide a convenient solution for blocking RF, EMF, microwave, and RFID signals from phones, key fobs, and other devices, ensuring privacy, security, and reduced exposure concerns. However, no reputable manufacturer offers a single product that fully integrates broad-spectrum signal blocking with dedicated thermal protection. Pairing a high-quality Faraday bag, 100 kHz, 40 GHz, 80 to 100 dB, MIL, STD, 188-125-2 certified, with a neoprene or silicone thermal sleeve achieves maximum protection, addressing electromagnetic and heat-related risks. Additional considerations such as magnetic fields, chemical exposure, and physical damage can be mitigated with specialized pouches, hypoallergenic linings, or durable materials. This dual approach ensures comprehensive safety in a pocket-friendly format for today's wireless world.